year 10, our final exercise on rationalizing the denominator. The first core understanding we need to have is that when you multiply a third by itself, so for instance root 2 times root 2, the final result, root 4, will end up as 2, which is the number inside the third. So root 2 times root 2 equals 2. Root 3 times root 3, if we take the extra step, comes out as the square root of 9, which simplifies down to 3. So root 3 times root 3 equals 3. This is very useful for when we want to try and remove a third. So, thirds are conventionally written with rational denominators. What that means is that if you have a third underneath, if you have a third as the denominator, you need to rationalize or remove it such that that bottom value, the denominator, is a rational number. There is no third. The way that this is done is you multiply by the third which is on the bottom, in this case root b, both top and bottom. Okay? We're going to demonstrate this in A. You have 2 divided by the square root of 3. If you multiply both top and bottom by the square root of 3, root 3 over root 3, the top will become 2 times root 3, or 2 root 3, and the bottom will become root 3 times root 3, which we now know is just 3. For B, we have 5 over the square root of 7. So once again, we will multiply by the square root of 7 over the square root of 7. Okay? Multiply by root 7 over root 7. The top will become 5 times root 7. So 5 root 7. The bottom, or the denominator, will become root 7 times root 7, which is just 7. Finally, we have C. Now, from index laws, we know that the square root of a fraction is the same as the square root of the numerator divided by the square root of the denominator. Okay? So root 3 over 7 is the same as root 3 over root 7. Now, the root 3 on top is okay. The root 7 as a denominator is what we're going to try and fix. So, we are going to multiply by root 7 over root 7. Okay. This does not change the number, as root 7 divided by root 7 is equal to 1. So, essentially multiplying by 1. The top becomes root 3 times root 7, which is the square root of 3 times 7. Divided by root 7 times root 7, which is 7. So we end up with the square root of 21 over 7. Okay? We rationalize it. We change it so that there is a rational number as the denominator. Example 2. We're looking to rationalize the denominators in the following. Now, in these examples, there is a third in the top and the bottom, so the numerator and the denominator. The process is still the same. We're still going to multiply A by root 6 over 6. Or root 6 over root 6, sorry. That's going to give us 3. The thirds will multiply together, so we have root 6 times root 5. We get root 30. Divided by 6. Now, while we have rationalized the denominator, this is not our simplest form, because you will see that we have a 3 and a 6, which have a common denominator of 3. So, we will rewrite it. 3 divided by 3 is 1 root 30. 6 divided by 3 is 2. So, it's just root 30 over 2. For B, we have root 2 over 3 root 7. We only have to rationalize the third, so I'm not going to multiply by 3 root 7, I'm just going to multiply by root 7. It's a very important point. You don't just multiply by the whole denominator, only the third part which you wish to rationalize. The top will be root 2 times root 7, which is root 14. the bottom will be 3 times root 7 times root 7. And I've drawn this out explicitly just to show you that we have our root 14, but then our 3 times root 7 times root 7 is going to become 3 times 7, which simplifies down to root 14 divided by 21. Finally, we have 3 root 5 over 2 root 10. Okay. Once again, we're going to multiply by only the third component of the lower half. So, we're going to multiply by root 10 divided by root 10. And we will get 3 root 5 times root 10 is root 50 over 2 times root 10 times root 10, which is just 10. Okay? We continue on. We can simplify root 50. Root 50 is 3 times root 25, which is our square factor, times root 2, all over 20. Square root of 25 is 5, so we're going to have 3 times 5 times root 2 over 20. I'm just going to bring this up so that you can see it a little bit clearer. Alright, so 3 times 5 is going to give us 15 root 2 over 20. And now we can simplify. 5 goes both into 15 and 20, so this will become 3, and this will become 4. We will end up with a final answer of 3 root 2 divided by 4. Okay, a more complex example, but the process is the same. You rationalize and then you simplify. Finally, rationalize the denominators in the following. You'll see at the top that we actually have multiple terms in the numerator. So, we have, in this case, 5 is one term, and root 7 is another term. So we have 2 terms in the numerator. This means that we're going to have 2 multiplications when we rationalize. So we're going to multiply by the square root of 3 over the square root of 3, which, when we multiply the top, is going to be root 3 times 5 and root 3 times root 7. 2 multiplications. Alright? Root 3 times 5 is just 5 root 3. Root 3 times root 7 is the square root of 21. Our numerator is root 3 times root 3, which is just 3. Okay? That cannot be simplified any further. Looking at B, we have 4 root 5 plus 3 root 3 divided by square root of 10. Again, we multiply by the square root of 10 over the square root of 10. Okay? It's going to multiply with 4 root 5 and with 3 root 3, 2 multiplications. So root 10 times 4 root 5 is 4. Root 5 times root 10 is root 50. Plus 3 root 3 times root 10 is root 30. Divided by the square root of 10 times the square root of 10, which is 10. Now we're going to simplify our surds if possible. The square root of 30 cannot be simplified. Factors are 1, 5, 6, 10, and 30, and 15. Okay? Square root of 50 can be simplified. So we're going to have 4 square factor of 25 times root 2 plus 3 root 30 divided by 10. 4 times the square root of 25, so the square root of 25 5. So it's 4 times 5, which is 20 root 2, plus 3 root 30, divided by 10. Now, we cannot simplify the 10, even though 20 can be divided by 10, 3 cannot. So this is our final form, our final answer for this question. Alright, this is our final exercise. Good luck with the exercises. I'll see you on Thursday.